It's Friday, 4 p.m. here in Berlin. Hi, and welcome to Telemetry Drops. It's been a while since we last spoke. So last few weeks have been very, very crazy for me. The Oli Garden side of the house is taking it's taking a lot of time for me. Well, not taking, but really requiring. I think that's the right word for that. But things there. They're moving really fast. But anyway, so this is Telemetry Drops. This is not Oli Garden today. And this is our first live stream since a while now. Now, I have a few things to call out before we call our guest in here. A few things are, so first, we have a couple of events lined up. One is the notifications for KubeCon. They're coming up soon. So in a couple of weeks, we have the notifications for KubeCon. I saw some of the things that happened there. So I was part of the co-chair for the observability track for KubeCon, and I'm very happy with the quality of the proposals there. So very good. I'm very happy. I'm really looking forward to KubeCon in Salt Lake City in November this year. Second thing is SignalsConf. So there's a new conference here in Berlin, SignalsConf. It is taking place I think it is September. And it aims to be the successor of Monitorama, but now here in Berlin as well. The main focus is on AI plus observability, so this intersection of areas, or are AI and SRE. I think it is not necessarily observability. And it is very promising as well. So if this event is not in your radar, if you are close to Berlin or close to Germany, then do consider joining this event. Next week, I'm at We Are Developers. If you are in Berlin next week for We Are Developers conference, then say hi. I'll be there talking about the open telemetry mistakes that I've seen, or the most common open telemetry mistakes that I've seen. If you've been following us here for a while now, then you know some of those mistakes. If you don't know which ones they are, or if you have ideas, leave a comment here. I want to see if you know me as much as you think that you do. So leave a comment here. There are some mistakes that I keep seeing no matter which companies I look at the telemetry. I keep seeing those mistakes, and next week I'm going to review which ones they are. I'm going to show some examples, like practical examples based on real examples. Of course, they're going to be synthetic, but based on things that I've actually seen in production, and I'm going to bring that up to you. So those are some of the things that we have in mind. The CFP for Observability Day has also closed. We are also reviewing the proposals for that. Also very, very cool stuff there. So also looking forward to that. So if you're planning on going to KubeCon, plan as well for arriving a couple of days earlier for Observability Day. All right, and I think we have also Observability Summit sometime in Prague. I think it is co-located with the Open Source Summit. I think it is September as well. I'm very likely going to be there for a co-located event, so not necessarily for Observability Summit, but perhaps we can see each other there as well. So those are the main events, the major things that we have lined up for the next few months. And with that said, I think we're now. Oh yeah, and perhaps another two callouts before our guest comes in here. First one is, I'm very happy that I saw that another person passed the OTCA exam, the Open Telemetry Certified Associate, using our exam preparation on telemetrydrops.com. So go to telemetrydrops.com. There is a exam preparation link up there at the top menu bar for the website. It's free. Just go there. The questions that I designed for that preparation, they're harder than the actual exam. So take those. They follow the same pattern in terms of the structure, like the amount of questions, the timing that you have for that, the level, the areas of the questions. So how many questions about instrumentation, how many questions about collectors and so on, semantic conventions. Those are following the same structure as the actual OTCA test. But the questions are harder. So if you can pass, my promise is, if you can pass the preparation 3 times in a row, then you are ready for the actual OTCA exam. So you can go there and you're going to find it easy. So that's a promise that I can give you. So this is one thing. And the second thing I forgot what it is. Oh yeah, the Telegram channel. And we have a Telegram channel, so join Telegram channel. So t.me/telemetry drops, if I'm not mistaken. But look for the Telemetry drops channel on Telegram. So we exchange some information there. It's not too crowded, but there are quite now and then we have a few good threads there, a few questions, and people answer them, other people there. And that's also the place where I share the MP3 files for the Hotel Drops podcast episodes before they go live on Sundays. So on Sundays, we have Hotel Drops, a podcast with the news from the community, from the Open Telemetry community, and I share before on Telemetry Drops, the Telegram channel, to get the feedback from people. So that's it. With that all said, I'm going to call my guest here. And let's, Hey, Mike, how are you doing?
Hey, thank you. Yeah, I'm good. Thank you. How are you?
Very good, very good. Mike, you are known in the community, but for those who don't know you, introduce yourself. Feel free to introduce yourself.
Yeah, of course. I'm Mike Goldsmith. I work at Honeycomb on observability. So primarily work through Honeycomb and into Open Telemetry, talking about all the different tools that customers use, that people in the observability space use. Worked across many different facets of Open Telemetry. So worked at the spec level, worked on SDKs, worked in the collector, lots of different areas, and try to make sure that all of it works together and works as best as it can.
How did you get into this area? Like, were you a practitioner of observability before, or did you join to build the tools already? Like, tell us your story.
Yeah, so it's probably about 7 or 8 years ago, and I was working for a company. It was a NoSQL database company, and they were really interested in learning how they could add observability to their telemetry, both from an SDK and then their server backend. And they would become interested in open tracing and open metrics, which were the predecessors to what Open Telemetry has become now. So through that project and those series of projects, I worked with it and really fell in love with observability, what it can do, how it works, what it gives back to people that are interested in it. And then through that, I ended up moving into the space and started to work on them, like look for a role that I could work on in the community and then on the tooling directly. And I've been in that space for, I think I've 6.5 years now. So it's been quite a while.
Has it been 6.5? Okay, that's a long time now. That's so you were around by the time that Open Telemetry became Open Telemetry then, right?
That's right, yeah. So I think it was just as Open Telemetry, Open Metrics were like could be coming together. So I've heard
Open Census.
Open Census, yes. Open Census and Open Tracing, like those two projects decided that it's probably better to work together rather than have two separate things that are trying to tell a very similar story.
Yeah, nice. You mentioned you've been around for some different areas of OTel, semantic connections, SDKs, and APIs, and so on. But what about the collector? Like, what are the things that that you've done for the collector before we go into the drain processor? So what is catching your attention when on the collector land?
So I've been involved in the collector for quite a while. I think most serious users of Open Telemetry either start with the collector or they move on to using the collector. It's just seen as a core piece of infrastructure that anybody that's got a serious observability pipeline now. So the things that I've been interested in and worked on, and previously I've done a lot of work in being able to ingest Azure logs and metrics into them. So through translators and receivers. I've introduced a couple of processes. So I'm a code owner on a number of components in the Contrib project directly. So we'll end up talking about some of them, but we've done one that works well with the drain process that we'll go on to talking about is the log DG process. So that was contributed 1.5 years ago, and that's doing really well, and people like to see that working as well.
I don't know if I've ever told you that, but I love the log DG processor. One of the things that I like the most is going to people and saying, do you want to get a raise? And I can tell you one trick that can get you a raise at the end of this year. Look at your observability bill and apply this processor and look at the savings just after this one processor. And then you can go to your manager and say, what, I'm saving the company X amount of money and I deserve a raise.
Yeah.
Because that's so nice. That's so good. I mean, of course, it does require some more processing, especially like memory. It consumes a little bit more memory.
Right.
But the final results, like the outcome is really, it's wonderful. So thank you for that.
Yeah, and we've had a very similar story of people we've talked about it and shown it to, and they've had a very positive experience of it. Is you're right, it's got some awareness of how it works, but if you treat it well, it'll treat what comes out of it really well, and you can get a lot of benefit from it.
Nice. For people who are watching, if you have any questions, if you want to know anything about the Drain processor or anything at all from Mike, leave your comment here. This is your chance to ask Mike questions and have him answer live here. Nice. So Drain processor. So can you tell us a little bit of story there? I see that there's a paper behind it.
That's right.
The paper is actually very, very interesting, but tell us more.
So it was originally 2017-ish or so. There was a research group that came up and was trying to talk about how to do log processing and at a very high level. And they came up with the Drain algorithm. And the Drain algorithm is essentially looking at a series of characters and trying to tokenize it. It's trying to look for things that are of high cardinality and low cardinality, things that are repeated within that string. And then try to say, how do I know when when one log line looks like another log line? And can I make some sort of assessment that if I see something many times, where are the variable parts in there? And then from that, it will generate a template, and then the template will grow over time. So it uses a tree algorithm. So as new log lines are seen, it then generates new entries and new leaves. And then it tries to generate as many templates as it feels appropriate based on its configuration. So probably the largest implementation of it is through Drain 3, which is a Python library, and that's maintained by IBM. And that's been around there for quite a while, and it's been quite useful in Python. But there isn't as much use of it outside of Python. So I did some research, and we sort of saw the opportunity here, and then there was a library that was available that introduced that. So we built the processor around that library, that Go library that can apply the Drain algorithm.
Do you remember which library is that? I don't remember seeing that one specifically.
I can't remember the name of the library. I can probably find it very quickly.
It's okay. Yeah, I mean, it's okay. It's fine. So let's go back one step. And I like the technical aspects of that. I like the paper. But can we go back a little bit and see why would you want the Drain processor? Like, what is the problem that it's solving? Who is it benefiting the most, and who is likely not going to get anything back from the Drain processor?
Right. So typically, when people see a high volume of logs, they very rarely are fully identical. Like, you'll have a variable part in it somewhere, like a user ID or an IP address, or sort of like a date timestamp or something like that, which means that something like the dedupe processor wants to look across the whole log body and then compare them side by side, and it'll take it byte by byte. So if those things aren't identical, then it doesn't know how to dedupe across them. You can do things like try to remove the things that change over time. So you could do like a regular expression and pull them out, or if you could anonymize them yourself. That's options, but that requires somebody that's actually doing that to know what the variable parts are before you can do that. And then if a new log starts to be generated and sent to your system, you've got to see it come through the system, see the impact, and then make the choice, is this something that I want to try and redact a little bit out of to try and make it more generic so I can do deduplication on it, or I can decide to do something with it in the other way. What the Drain processor does is it actually flips that. You don't need to know anything about the logs that you're sending. The algorithm can start from zero, it can be seeded with nothing, and then you give it every log and it just runs it through and it learns from that. We've introduced a warm-up period, so while it's going through the first X amount of logs, it won't try and generate a template for you. What it'll do is it'll just learn from that and then try to build its tree. And then when it gets to a certain level of consistency, then it will know that I can start attaching, like actually give you a template based on the logs that it's receiving. So you don't need to know, the algorithm and then anything behind the algorithm doesn't need to know what all of the template looks like. And it doesn't need to care what the variable part's in. It'll be given a consistent template that then you can choose to make assessments on, whether that's just storing and understanding how many of each template you see, or you could filter them out if it's like a health check and you don't care about it, or you can do something like the dedupe processor, and then tying them together means that you generate a template that removes all the variable parts, and then you're something like the dedupe processor can really work in tandem with that, because then you can dedupe on the template.
Right. So let me see if I got some of the cases there. So one, this is mostly for the hot path logs, right? So this is very likely not for the bootstrapping and the background processes logs. Like those are typically not very noisy. So perhaps you are not going to get much out of those. But for the hot path, you do.
Yes, right. So it's same as the log dedupe processor. The higher the volume and the volume, the higher the volume, the more value you'll get from it. So if it's infrequent logs, it will remember them. But if you only send a few at an application startup, you're not going to benefit from it long term. But if it's something that is generating consistently through an application or some sort of process lifetime, then you will see the value over time. Yes. The algorithm is really good at making sure that it is very heavily optimized as well. So the learning process and then the lookup process is extremely quick. So it doesn't have to constantly do a train and then assessment, then a train, then an assessment. So it's built to be in the hot path. So all of your log volume can go through it, and then it can do that assessment for you.
That's interesting. Anyway, I have so many questions going there in that direction. But I think going back for the people who don't have the same context as we have, like I've seen the code and I appreciate the code. That's what I love about open source. You can just go there and learn. But the way that it works is, so logs go there, and instead of changing anything in the log message, so it doesn't try to change anything in stream, right? So right. It only adds one more attribute that you can specify. If I remember correctly, you specify the name of the attribute that receives a template. And the idea is later on, I, as an admin of that system, as a platform engineer or observability engineer, I can go to my backend and I can group by those patterns, and I can see which ones are most frequent. And then I can use my human judgment, or perhaps AI is in vogue. So AI can then decide how to transform those patterns with stars into regexes or in my pipeline. Is that how you envision that working?
Yes, pretty much that. Yes. So the first step that anybody wanting to explore what the drain processor can do would be, don't do anything with it in the pipeline. Let the templates be added. And you're right that it adds a new template. So it doesn't change the original log body, because we don't want to change the log body, because there might be something interesting in that log body. Like if a particular user is being affected by something, or an IP address, or a user, or like some sort of service that you need to know in that log body is still interesting. So the drain processor creates the template and then adds it as an additional attribute. Then in a backend system or whatever system you want to apply, you can then group by it, understand what the cardinal, how many times you see that particular log over a particular window. And then, as you said there, you could either introduce transform processors to start extracting those things out, or you could introduce something like a filter processor or the log dedupe to try and act on that data before it leaves your collector pipeline, because typically a collector pipeline operates in your own infrastructure, and then it would be exported out to your preferred backend. So if you can choose not to send that data over the internet, it's a big saving for yourself.
So how would you see that on the life cycle of the adoption of that? Like, is that the first step then, what you mentioned, add the drain processor, it creates the patterns, and then you look at that. How would it evolve from that? Like, I found an access log there that should not be there. What should I do then? Do you see the next step as the filter, like just remove it, or transform to, or perhaps signal to metrics to convert those access logs into metrics, or just keep them and make statistics? Like, what are the possibilities there? You kind of mentioned some of them, but how do you like it?
Yeah, so there's a lot of options there. So yes, the first step, the lifecycle first step, add the drain processor and see what's being templated, what your templates look like. Can you see any patterns that you think, I didn't expect that log to be there, or that log is occurring at a much higher rate than I would have anticipated? And then you can start to make better choices with what that log looks like, whether that's making like a telemetry change, have something that emit less frequently, or do a transform processor and say, okay, I care about this information and I now want to pull out, I know what the attributes that the template is showing me, so I can extract a particular variable in there and add that as an additional attribute. So going back to what we said earlier, is typically somebody that runs a logs pipeline, they need to be aware of all of the log shapes and what their log looks like, for them typically to pull out information that's relevant to what they would like to see in an attribute that they could then query on independently. But you've got to know that beforehand. You've got the transform processor, you've got to say, I expect this pattern available and I want to put it into this named attribute. The template that is generated from the drain processor identifies those for you. So you can then say, okay, now I know what that attribute looks like. I can then write a transform processor that will then pull it out for me. I've actually got some ongoing work in the collector contrary project where the drain processor will actually create an array of all of the parameters that it did create a template for. So the template will be there, and then all of the placeholders of the things that it thinks are variable, it will then add as an additional attribute of just an array of those values. I think that would be quite useful, because then someone could then reasonably look at the template and say, element number 4 is actually this value in the array, and then I know what that means, and now I can start to think about that slightly differently.
Yeah. So one thing that we've done for a specific customer was we used the drain processor to expose the patterns, and then we found one of those access logs there, and we used the signal to metrics to convert logs into metrics, and those gaps, or those holes that they were saying, like the rays there, they would become the attributes on those metrics. Yeah. So if I remember correctly, on that specific log, so it was envoy logs, and they are very noisy, right? And so we had, like, the path was an attribute, the method was another attribute, and the beauty is there is even a semantic convention for those metrics. Like, there is a metric name specifically for HGP operations, and then the parameters as well. So it was just a matter of moving from one to another and converting those to metrics that provided, like, that saved a lot of data points from those companies, from that specific company. So that was very useful. So, and I guess I go now into a similar question, but with a different view. In my experience, most of the logs that I see with a huge amount of repetitions based on those patterns, they should not be logs in the first place.
Right.
Like, is that your experience as well? Is that a controversial statement, or do you think it is consensus?
I think I would agree with that as a broad stroke. Yes, I think that a lot of log lines are trying to convey some sort of activity that could be a metric instead of a log. But I think for many people and many old systems, logs was the way to convey that information, and they've never come back and thought, well, how could I retype this into a different signal? Because I think observability comes to applications probably a long time after the application has been around for a while. So re-instrumenting and re-changing how you think about what telemetry comes out of it is an effort. So having something like the collector be able to identify where opportunities are to change the data type or to change what you're seeing is a really good thing. And yeah, metrics tell a very good story, and they tell it in a different way to what logs can.
You mentioned one thing, that most of the legacy applications, or most of the older applications, they use logs as the main signal. Is that only the applications? I have the impression that we are in a bubble, that we like traces, we even like metrics for some part, but most people they only know logs.
Mhm.
Does that match your expectation and your experience as well? Do you see people caring more about other signals nowadays, or do they know logs the most? And then observability engineers look at the pipelines, they see, oh, there's a new service right now and it still uses logs.
Yeah.
Or do you see
I
more
think,
traces?
yeah, I think for somebody that's been in the space for a long time, whenever I speak to somebody, I always hope that they know what traces are. I would say the majority of the time people are working toward traces, like they understand the value that traces can have, but they're typically more likely to use logs and metrics. Logs, I would say, is probably the highest volume of data that comes out of a typical application that hasn't been built with observability at the forefront of like people that know what they're doing and how to design systems with observability in mind. Logs is the primary source of data coming out of that system. Yeah, I would like to see more people move towards traces, and I think one of the nice ways that I like to explain traces to somebody that is just familiar with logs is that I call them fancy logs. It's just got two extra attributes, which is a trace ID and a span ID, and those two things let you correlate a series of things together, create a trace graph, and that's all it is really, is two additional attributes, and you can see a lot more data and get a lot more value from the same log effectively.
Yeah, it's so funny. I call them logs on steroids. And I actually add one more attribute on top of that, which is a duration. Right? So the duration is also something that logs don't typically have. They have the timestamp, but not the duration of the transaction. But then the parent span ID and the trace ID, those are or the causation, the causality is what really sets them apart. Right? So what caused me? What is my parent span ID? So this is our hope. This is what we want for. That's what we want to believe that most people would use if they know about them. But do you think this is okay? We are going too far from the drain processor now, but this is so interesting. Do you feel like most of the cloud native applications out there, they're coming with good observability out of the box, like from the developers, from the agents, and so on? Or do you feel like there still needs to be a lot of education there to tell people, there are 3 signals, like you can use them, or even even ignoring profiles, right? Like there are things that you can use other than logs. Or do you feel like people know them and are using or starting to use them properly?
I still think most people are predominantly on logs. I think that is the main medium that people
even for new workloads. Yeah.
I think if an organization has dedicated resource in their system, like they've seen the value of what observability can do for their system, and then I think it's much more likely that as a new system is introduced to their organization, or they're starting like a really true greenfield operation, they'll think about it differently. But I don't think that happens all that often. So a lot of the time, when I start speaking to people that are interested in learning more about observability, they've got a really good log story, a really, really good log story. They might have a metric story, but it's not as like complete. And then nearly all the times, like, we understand that traces are valuable, but they haven't quite had that aha moment of why it's good, what else it can do for you, why it helps, it adds so much not complexity. It adds so much more context to what something happened and the why. And I think that's the really interesting part of like the sequence of operations, why one thing led to another thing. So metrics is really good at telling you that something happened, but it can't tell you why. Logs can tell you individually this thing happened, and then traces say this thing happened because that thing happened, because that thing happened, because that thing happened. And that really helps tell a much larger, bigger narrative of what's actually happening in a system and why the things have gone in a particular direction.
Yeah. No, we can go so much deeper there. We can go into observability signals, and but let's go back to the drain processor for a moment. What do I need to know when I operate a pipeline with a drain processor? Or in other words, the favorite question from every operator when a new tool is introduced? What is the performance implications of that? Like, what should I expect in terms of CPU, memory? Should I provision more collectors for that? Or is it lightweight enough so that my current collectors are not going to feel it?
So it is extremely lightweight. It's intentionally built that way. So there's some configuration options of like how big you want your tree to be. So if you've got a very, very high number of log options, you might want to increase that. There's a default, I think, of like 1,000 different variations of log lines. But a complete tree, so through throughput testing that we've done of sending like 100,000, 200,000, a million log lines of varying lengths and things, a complete tree that is serialized into JSON is 30 kilobytes. So it doesn't need an awful lot. And that's both operating memory, and then the drain processor has the option to store that tree and then reinitialize itself the next time it starts. So you don't have to go through a training phase. So there's a very small overhead there, and that takes advantage of the new collectors storage extension. So you could actually write that to a file that's then shared across a whole fleet of collectors. And then as a new collector instance starts up, it just says, oh, there's a tree already pre-built for me. I'm just going to load that and then start working immediately. So the operational side is very, very minimal. There are some things you can tweak on, like how deep you want the trees to go, how many nodes you want to be available to you, what the threshold is. So something we haven't touched on too much is that through the algorithm, it talks about like a similarity threshold, and that's how close one log looks to another log before it sees them as different. So if there's a little bit of variety in there, it might categorize them the same way, like the number of placeholders are in there, for example. But then that's a configuration option. So if you feel as though that you're seeing logs that maybe should be separate, you can then decrease the similarity rating, and then you'll start to see the algorithm will then trade to move them away from each other. But yes, operationally the lookup process is extremely quick as well, because it effectively creates a lookup map. So it doesn't have to do very much other than give the log body, and then it gets a lookup value back. So, and then the training happens behind that.
Is it then more CPU bound then, from what I'm getting? So it does see the tree, it stores in memory. Memory is like a memory operation is very fast and not frequent from what I understood. And then it's mostly CPU, like checking for each log line, checking which entry in the
that's right.
in the tree. Okay.
Yeah.
And how does it work?
How does it work? So the train algorithm effectively looks at everything through the startup phase. It doesn't return a template. It just says there's no template. I don't want to give you one yet. Once the tree is matured enough, then it can start to give you a template back. What happens is each time a log comes in, it then looks at that and then says how many items are in here, what's the delimiter that I can provide to you? Is it space delimited? Is it comma? Whatever you decide the delineation between those different components are. It then does things like, for optimization, it'll do how many items are there, and if it knows that there's 7 items, it knows to only look down the tree that are then have 7 items in there, and it can do that. So it's a very fast lookup tree algorithm based around optimizations that way. And effectively, then it'll decide that it'll land on a node. It'll then add that additional log to that node to give it some weighting, and then it'll take the template and then return that as a value that you can then add as an attribute.
Nice. That's so cool. Would you apply the drain processor as one of the last processors in your pipeline, or as one of the first ones?
I would do it as early in the process as possible, because I would make sure that there's anything like enrichment that happens. I would try to make enrichment happen. And then before you actually act on any data, I would try to do that as early as possible, because if you've got something that you want to dedupe, or if you've got something that you want to filter away because you don't want it, or convert to metric signals, you want that to happen as early as possible, so it comes out of the logs pipeline and goes somewhere else or does something else instead.
So after those transformations, after enhancement and enrichment, but just after that, is that what you are saying? Okay.
Yeah.
Does it take only the log body into consideration, or can it also use the other attributes or other parts of the log record as an input?
You can select. So it defaults to log body, and then you can tell it if you prefer it to look at a different attribute that you've done something else with in your collector pipeline, or if you decided to extract something previously, you can tell it to look at a different value.
Okay, so that was something different that I had in mind, but that's interesting. Why would I do that? Like, can you give me a concrete example?
I guess if you've got a log body that you know is some sensitive information in there, for example, and you want it preserved, you want to redact that before it even goes through the log templating system, you could then do it that way. So you could have the log body, the raw unchanged log body, redact it, and then give that value to the drain processor and dedupe processor, so they never even see the unredacted forms in which, as we said before, is the drain processor is actually storing a tree of it, so it will know what those structures look like.
Interesting. Okay, so that's very cool. I had in mind something else, like not looking at a specific different attribute than the body, but a combination of those. Like perhaps look at the specific attribute here to see, like, this is the username, and then use that as a hint to search for the username on the message. But that doesn't make sense, right?
I don't think so. I think, yeah, what you're ultimately trying to do is generate that template. So you're trying to replace the items that have some sort of like variability with a placeholder. So then you've got a consistent log template. So it's a consistent string, and then be after the drain processor. So there was a clear when we were developing that processor that we didn't want the drain processor to actually manipulate any data in any way. So we've left that to other processors, other things, backend systems, whatever that looks like. They can act on the template and make decisions and transform, drop, dedupe, whatever that looks like.
Mm-hmm. That's cool. So most of the time, people have multiple layers of collectors. They have like edge collectors, they have central collectors, and then perhaps a collector that is just before going out of their premises. Mm-hmm. Where would you apply the drain processor there? Like last mile or edge?
I would not put it on the edge, because I think you benefit more for having more logs go through it. So if you've got an edge that only sees certain applications or certain infrastructure things, then it won't learn about all the other things. So I think having a one that sees everything, that means that the drain algorithm has more opportunity to learn and then share that context through the storage and the reading or writing of the tree into a local file, and then that allows a much faster startup process if a new instance comes online, because it's got a fully developed tree that it doesn't have to warm up through.
Nice. Yeah, that makes sense. You mentioned as well that you could use the local files, like with the storage plugin. Storage extensions. I'm with the Jaeger mentality now. It's not storage plugins, storage extensions. And you mentioned that you could share the same file across multiple collectors. Would it work? Like, is it really that we could share the same file for writing purposes, or you're saying that you should take like one snapshot of those files and distribute the same file like multiple times, or all collectors would write to the same bucket, to the same file?
We've done it with a hashing algorithm, so that as the tree learns, all of them will try and store, and it'll do a hash against what the current value is, and then read it and say, if those two things are equal, I'm not going to try and write that. And then we've got like a deterministic write process where it will try and write, and if it fails, it'll then reread and then see if it's changed again. So multiple instances can choose to write if you want to. I think there's configuration options in the processor to say how often you write, whether it's periodically or you expect, you've had a processor running for a long time, you've taken a copy of that tree, and now you don't want them to save anything anymore. You could do that as well. So yeah.
Nice. So that's very cool. So there is a writing protection, like it doesn't override what other collectors are doing, so you can safely share for read and write across the collector instances.
That's right. Yeah.
Okay. No, that's very cool. Nice. Mike, you mentioned one of the next steps for the drain processor. That's with the array of values. What's next? What else is there?
So an extension to that would also be so the original drain algorithm and then the Python implementation applies some regex. So you could give some regular expressions to the drain processor. So as it's extracting those placeholders, it will then apply the regular expression to see if it can categorize it and actually name them. So for example, if you've got like a username and you know that the username follows a particular pattern, when the drain processor creates a placeholder for it, you could apply a regular expression and then say, I know this is a username. So instead of it being an output of an array of values that have got placeholders, it would actually be a key value map, and it'll say the username was this, the IP address was this, the what other values what other placeholders generates, it can actually name them as well, which I think will be a lot more interactive for people to understand what's in there. Because I think the first step of exposing those parameters, you've got to look at the placeholder, look at the array index, and then sort of figure out what it means. So I would like to see if we could extend that to actually name those parameters as well.
That's very nice. And what is next after the drain processor? Like any new ideas to complement that flow? Because I see the drain as part of a bigger story. Right? So the drain plus the filter and plus the dedupe, they're part of the same story. They are part of. I see a lot of bad logs out there, and I want to optimize them. I want to make sense of them. What else is missing? What is also part of this story?
I think a lot of the tools that are already available now. So I think between the drain processor, the filter processor, the log dedupe, the logs to metrics connector, I think there's a lot of tools available to you. I would say that the next thing is probably putting them together and showing how they work together well. So blog posts, documentation, use cases, all of the things that say this is the right way to use these tools to get the most benefit from them. The same as everything with the collector and many open source tools. The tools can be really good, but the description of how you're meant to use them and what use cases you would like that you're going to get the value from is sometimes a little bit lacking. So I definitely see education around how to use those tools and what the benefits each of those options have is probably the next step.
Nice. Looking forward to your next KubeCon talk on the topic, because it feels like a very good KubeCon talk to me. Mike, anything else that you want to share with people? Like, where can people find help if they need, and how can they contribute to the drain processor?
I'm Mike Goldsmith on GitHub. I'm in Slack, in the CNCF Slack a lot of the time. So there's dedicated channels to both the collector development. I'm in the sampling SIGs and lots of other places. So typically very easy to find in those areas. The drain processor, the log dedupe processor are all available in the collector contrib repo. So if you want to go and have a look at the source code there, feel as though that you want to contribute. You can create issues, you can open pull requests, you can message me on there, and we can figure out what would be good to add to those processes.
Nice, wonderful, cool. Mike, thank you very much for coming to Telemetry Drops and showing a little bit about the drain processor. The documentation for the drain processor is quite complete, and it's actually quite easy to use the drain processor. You just specify drain in the collector config and attach that to the processor list, and that's it. That's a good way to get started. And then you can tweak the drain processor using all the options that Mike mentioned, the training size and the amount of well, you can tweak it. I think you can configure the greediness of the algorithm as well, right? So I think that's right. That you mentioned as well, yeah. So give it a try and poke Mike if you find any problems. You know now where to find him. Mike, thank you very much.
Thank you very much.
See you next time.
Bye.